Hi, today we're going to start talking about center of mass velocity on our second installment in Momentum. And I want to talk, we said last time that if you have a system, the center of mass of the velocity stays constant as long as there's no external force to that system. So if there are no other forces acting on that system, the velocity of the center of mass is going to remain the same. And so if we look at this system of two objects where we have a 5 kilogram mass is moving at 10 meters per second and we have another 5 kilogram mass that's not moving, we can look at the velocity of the center of mass and we could find the velocity of the center of mass of that system. And if we know that it remains constant if there's no external force, then that means if these two guys hit, so they hit, and then we have the situation where we have both of our 5 kilogram masses that are stuck together, we know that the center mass of velocity after remains the same. And so we can say that mass 1 times the velocity of the first object plus mass 2 times the velocity of the second object after will equal what it was before. And we know that because center of mass velocity remains the same. And so if we look at this is a mathematical equality. And if we have these two things equal to each other, we can cancel these terms and we're left with an equation for momentum. And you might remember that from last year. And so if we look at this quantity is called momentum. And you might remember that momentum is mass times velocity, and by mass we mean the inertia, and velocity, V stands for velocity, and this quantity is known as momentum. And momentum has the symbol P, and Newton called it the purposeful motion of an object, so that may be where the P comes from. But if we look at this, then we know that the momentum of the first object plus the momentum of the second object is going to equal, even after, the momentum of the first object plus the momentum of the second object after. Now the momentum of the first object might be different than it was before, but the momentum of the system is going to remain the same. And so this is essentially saying that the momentum initially equals the momentum final, and this is known as the law of conservation of momentum. Okay, and this is found in states where there's no external forces present. If there's no external forces present, then the momentum remains constant. And so if we go back up to this problem that we had before, where we had our two 5 kilogram masses, and they eventually collided and stuck together, we could figure out how fast this system is moving after. And for a situation where we have the two objects sticking together, we can use the case of this equation. So if we rewrite this equation, this is our conservation of momentum equation. We have m1 v1 plus m2 v2 equals m1 v m1 prime plus m2 v2 prime. The prime is for the after. In the case where they're sticking together, like in this problem up here, we have m1 v1 plus m2 v2 equals m1 plus m2 times the velocity. And so we can use that to find out what's going in this situation, what's going on. And if we look at our 5 kilogram mass is moving at 10 meters per second originally. And our other block, our 5 kilogram block, is not moving, so it has a velocity of 0. We can figure out how fast the two blocks that are stuck together are moving after. And so when the blocks are combined, they have a mass of 10. And so we could figure out what is our new final velocity there. And so when we look at that, we will find that both blocks moving together have a final velocity of 5 meters per second. So let's look at another case. Let's look at the case where you have, let's get another 5 kilogram mass, and this time it's moving 2 meters per second this way. And now we have another 5 kilogram, and it's also moving 2 meters per second, but it's moving in the opposite direction. And look at that. Can you tell me what the velocity of the center of mass of the system is? Hopefully you can see by inspection that the velocity of the center of mass of the system is 0. Okay? And so what happens after they hit? And so if we look at this system, after they hit, there are 3 separate cases. And so if we look at that, we have case 1. When they hit and stick. Okay, and so if we look at that, if they hit and they stick, we have the situation like we had before, where we have the two masses stuck together. And so we could find out what is the velocity of this two mass system after. And so if we do that, if we have the mass of the first object times the velocity of the first object before, plus the mass of the second object times the velocity of the second object, and after they hit and they stick together, their combined mass is a mass of 10, we could find their final velocity. And if we do that, we could see that the final velocity of the system is 0. Okay? And if you have a situation like that, this is called a completely inelastic collision. Okay, and so the velocity with respect to the center of mass is 0. Okay, but we could have another situation. We could have the situation where a hit, and instead of sticking together, we have 5 kilogram mass moving this way at 1 meter per second. And we have the other 5 kilogram mass, and we don't know how it's moving. And so if it is this situation where they bounce, this kind of situation, if we look at that, let's go ahead and calculate. And let me draw a little line, a little bit close up there. So we have our original mass and velocity of the first one, plus the mass times the velocity of the second one. So now our first object has a velocity of 1. And we want to figure out what's the velocity of our second object. So we have v2 prime. So when we calculate what is v2, if we have, we solve for v2, we get 1. And so in this case, we have a situation where the object moves with less speed after the collision. Okay, so it has less speed after the collision with respect to the center of mass than it does before. So when you have this is known as an inelastic collision. And in this case, it loses, you're looking for the loss of energy. It loses energy. And we'll look at that some. The last case I want to talk about is where they hit and they bounce off of each other again. But this guy goes 2 meters per second that way. And if that one moves 2 meters per second to the left, then this one must be moving at 2 meters per second to the right if the center of mass is to remain at 0. And so both objects, in this case, both objects have the same speed. With respect to the center of mass. As they did before, they're just going in opposite directions. And so if we look at the kinetic energy for this, there is no loss in kinetic energy, and so this is known as an elastic collision. And in this case, there is no loss of kinetic energy. Okay. And so we'll pick up from there next time.